All right, welcome. Today we are stepping into the engineering ring for what is basically a title match decades in the making. In one corner, you've got the crowd favorite, the quick and easy Hazen-Williams equation. And in the other corner, the technically precise powerhouse, Darcy-Weisbach. This is the ultimate equation showdown.
So let's just jump right in. You gotta wonder, why would engineers, people who live and breathe precision and numbers, have two totally different ways to do the exact same calculation? It's kind of weird when you think about it, right?
Well, it all comes down to the fact that the stakes are incredibly high. The whole argument is about calculating friction loss in pipes. And believe me, this isn't some boring Homer problem. This one number is absolutely critical for designing anything that moves water. We're talking about the huge pipelines supplying your entire city, all the way down to the fire sprinkler system that's got to work perfectly to keep a building safe. If you get this number wrong, things can fail spectacularly.
Okay, so to really get this rivalry, let's head ringside and get to know our two contenders a little better. First up, we have the Hazen-Williams equation. You can think of this one as the reliable, old-school veteran. It's what's known as an empirical formula. All that means is it's based on a ton of real-world observation and experience, not just pure theory. Its entire purpose in life is to calculate head loss, which is just engineer speak for how much pressure you lose because of friction, and it's built specifically for water flowing through pipes.
Now, the secret ingredient for Hazen-Williams is this thing called the C value. It's the roughness coefficient. It's basically just one number that tells you how smooth or rough the inside of the pipe is. So if you look here, you can see that something like new copper or PVC has a really high C value. That means it's super smooth, not a lot of friction. A lower number means more friction, more resistance. Simple as that. And fighting out of the other corner, we've got the Darcy-Weisbach equation. Look, if Hazen-Williams is the seasoned veteran, Darcy-Weisbach is the younger, more versatile, technically brilliant champion. This one is built on solid scientific theory, not just observation. And that makes it way more powerful. It can calculate head loss for any fluid you can think of, not just water. But, and this is a big but, there's a catch. The key variable here is this little letter F, the Darcy friction factor. And that tiny F is where all of the extra work and complexity comes from. See, you can't just look F up in a simple table. You have to calculate it, and that calculation is what gives this equation both its incredible power and its reputation for being a pain. All right, introductions are over. Now it's time for the main event, a head-to-head battle. This is where we really see that classic engineering trade-off in action. Do you go for simplicity, or do you go for accuracy? It really all boils down to a fundamental choice. You've got the quick and simple approach with Hazen-Williams versus the precise and powerful approach with Darcy-Weisbach. So let's break down the pros and cons of each, starting with our old friend Hazen-Williams. In Hazen-Williams' corner, its biggest strength is just pure simplicity. It's so easy to use. You just plug in a few numbers, pipe length, flow rate, that C value we talked about, and you get an answer. It's fast, it's direct. No complicated extra steps needed. But you know, that simplicity comes at a price. It's kind of a one-trick pony. It's really only designed for water at pretty normal temperatures. On top of that, its accuracy starts to drift when you're dealing with really big pipes or water moving at high speeds. It's a fantastic estimate, but at the end of the day, it's still an estimate. Now, let's switch over to Darcy-Weisbach. Here, the name of the game is power. It is incredibly versatile. We're talking oil, gas, chemicals, you name it, it can handle it. And because it's based on the actual physics of fluid flow, the answers you get are way more accurate across a huge range of scenarios. So what's the downside? Well, the trade-off is complexity, and it's a big one. You can't just solve this thing in one clean step. The biggest hurdle is figuring out that friction factor, F, because it depends on a bunch of other things, like the fluid's velocity and its viscosity. It's just a much more involved process. Okay, enough talk. Theory is one thing, but how do these two actually stack up when the rubber meets the road? Let's run the numbers on a real-world problem and see the difference for ourselves. All right, so here's our setup. We've got a copper pipe, it's 500 meters long, and it's got a diameter of 150 millimeters. Our job is to push water through it at a flow rate of 0.05 cubic meters per second. So the big question is, how much pressure are we going to lose to friction along the way? First, let's use the quick and easy method. We take our numbers, we grab a C value of 140 for copper, and we plug it all into the Hazen-Williams equation.
And boom, we get an answer. A head loss of 23.12 meters. It's simple, it's fast, we're done.
Now, hold on. Time for the Darcy-Weisbach gauntlet. This is not a single calculation. It is a whole process. First, we have to figure out the water's velocity inside the pipe. Then, we use that to calculate something called the Reynolds number, which tells us if the flow is smooth or turbulent. Then, we use that number to find our friction factor, F. And only after all of that can we finally solve the main equation.
So, after all of that work, after running through all those steps and jumping through all those hoops, the Darcy-Weisbach equation gives us its much more precise result, a head loss of 17.47 meters. And this right here, this is what the entire debate is about. Let's put those numbers side by side. Hazen-Williams gave us 23.12 meters. Darcy-Weisbach gave us 17.47. That is a difference of more than 5.5 meters. In a real system, that is a huge difference. That could be the difference between picking the right pump for the job or picking one that either can't keep up or just wastes a ton of energy.
So who wins? Which equation is actually better? Well, you've probably guessed it by now. Like with most things in engineering, there isn't one single winner. The best tool always depends on the job you're trying to do.
So here's a quick and easy guide. If you need the absolute highest accuracy you can get, or you're dealing with really big pipes, high speeds, or literally any fluid that isn't water, then the choice is easy. You have to go with the precision of Darcy-Weisbach. But if you're just doing a preliminary design for a pretty standard water system and you need a quick, reliable estimate to get you in the ballpark, the simplicity of Hazen-Williams is often more than good enough.
And that kind of brings us to our final thought. For decades, the big trade-off has always been your time, doing the manual calculation, versus the need for accuracy. But I'll leave you with this question to chew on. In an age where we have incredibly powerful software that can run all those complex Darcy-Weisbach calculations in a fraction of a second, is the real winner today just the person who knows how to make the computer do all the heavy lifting?